All right, on to part 3 of our lesson on recursive rules. This last thing is using recursive rules, just using a different word for it called iteration. Now, in the last video, I mentioned the idea of iterating a function. Iteration involves the repeated composition of a function f with itself. The result of one iteration is the f of x. You remember f of g of x, that was composition of functions, meaning I'm plugging the output of one function into the other. The result of two iterations then is the f of x. Nice, huh? You can use iteration to generate a sequence recursively. Begin with an initial value, and here we label it as x sub 0 meaning the initial, and then x sub 1 would be the f of x sub 0, meaning what did I get when I plugged the first initial value into function f. X sub 2 then is the f of x sub 1. So once I figure out what x sub 1 is, I plug it into the function. That gives me x sub 2. And if I don't find the other one, I'm going to plug it in, okay? And so on and so forth. So it's kind of like having our friend the function machine. So in goes a particular value. So in goes, x sub 0, the initial value. And something happens to it. We plug it into function f, okay? And then out the other side comes the f of x sub 0, okay? The value of f when I plug in x sub 0. Now that is what x sub 1 is going to be, the first term, okay? To find the next term then, I take this value, whatever it is, and I plug it back in, okay? And then I get the f of x sub 1, that's x sub 2. And then I plug that back in, and then I plug it back in, and then I plug it back in again and again and again, okay? So I'm supposed to find the first three iterates of this function, 5x minus 3, with an initial value of 1. So if x sub 0, my initial value is 1, I'll write that here. That's supposed to be a little 0. Sorry. Then to find the first function, I'm going to find the f of 1, meaning I'm going to plug in that particular value. Hold on, let me erase that. That's sloppy. I'm going to find the f of 1 because that would be what I had previously, okay? The f of 1 means I plug 1 into that function. So I take 5 times 1 minus 3, and I end up with 5 minus 3, which is 2, okay? So that's now x sub 1. That's my, that's the next term in my iteration. So to then find x sub 2, the second term, I am going to plug in the previous output, which in this case is 2, okay? Only a coincidence that this is 2 and this is x sub 2. That's not going to happen all the time. It's just a coincidence, okay? So I'm going to find I take this and I plug it in. Find the f of 2. All right, that means I'm going to take 5 times 2 minus 3. So I'm using that same function, it's just it has a different input. And the input is the output from the previous iteration. So 5 times 2 is 10, minus 3, that's 7, okay? So now to find x sub 3, I am going to be finding the f of 7, because that was the output of the previous iteration. So plug in 7, and what do I get? Well, 5 times 7 minus 3. 5 times 7 is 35, minus 3 is 32. So there would be the first three iterates of this function with an initial value or condition of 1. So 2, 7, 32. That would be the answer that I'd be looking for, okay? Now your calculator is pretty good at doing this kind of stuff, again, like it was for the mosquito problem. If I clear this, my initial condition was 1, okay, or my initial value. So I'm going to hit 1 and hit enter. And then I'm going to set up my iterating function. My function was 5x minus 3. So I'm going to take 5 times the previous answer. So a little a and s down here above the minus or the negative symbol. Second that brings up a and s. So that means 5 times whatever the previous answer was, minus 3. I hit enter. 2 is the second iterate, or the first iterate I should say. Hit enter. There's 7. Hit enter. There's 32. So same three things, numbers that I got doing it by hand, I could have my calculator do that for me. And then if I wanted to continue to iterate this function to find the 4th, 5th, 6th, 7th, 8th, whatever iteration, I could just continue to hit enter on my calculator. So pretty slick. Questions? Ask.